Hello everyone. Today we shall discuss about dinitrogen. We know that nitrogen is abundant in the atmosphere. So it is obtained commercially by the liquefaction and fractional distillation of air. So let us see commercial production. So first air is liquefied and then it is subjected to fractional distillation. So what happens is liquid nitrogen, which has a lower boiling point around 77.2 Kelvin. So it distills out first, leaving behind oxygen. Oxygen boiling point is 90 Kelvin. So we'll get first nitrogen on a large scale. And the second method is laboratory preparation. So in the laboratory, nitrogen is prepared by treating an aqueous solution of ammonium chloride with sodium nitrite. So ammonium chloride, aqueous solution of ammonium chloride with sodium nitrite. It gives first ammonium nitrite is formed, which decomposes to give you nitrogen, water, sodium chloride. We can get nitrogen by heating ammonium dichromate. So by strong heating ammonium dichromate, it decomposes to give you nitrogen. And one more method is decomposition of sodium or barium azide. So in this case, we'll get pure nitrogen. So very pure nitrogen can be obtained by the thermal decomposition of sodium or barium azide. So these are the few methods of preparation of nitrogen. So let us see the physical properties of nitrogen. So in physical properties, dinitrogen is a colorless, odorless, tasteless and non-toxic gas. The dinitrogen has two stable isotopes, nitrogen 14 and nitrogen 15. And the third one is its solubility in water is very less. It is 23.2 cubic centimeter per liter of water at 273 Kelvin and 1 bar pressure. Now we'll see chemical properties of dinitrogen. See, dinitrogen is inert at room temperature because of high bond enthalpy of nitrogen triple bond. Dinitrogen is inert at room temperature because of the high bond enthalpy of nitrogen triple bond nitrogen. Here the bond enthalpy is delta H. Bond enthalpy is 941.4 kilojoules per mole. That is, the energy required to break nitrogen bond is very high. Therefore, nitrogen is highly inert and present in the atmosphere. But when we increase the temperature, the bond becomes weak and nitrogen becomes active and starts reacting. So first we'll see the reaction with metals. So lithium, nitrogen with lithium metal, it gives after heating, it forms lithium nitride. Similarly, nitrogen with magnesium, it forms magnesium nitride. That is, the metal nitrides are the products. One more very important reaction is dinitrogen with hydrogen. Here, dinitrogen combines with hydrogen at about 773 Kelvin in presence of a catalyst to form ammonia. So this is known as Haber's process. Here the enthalpy of formation of the compound is minus 46.1 kilojoules per mole, and dinitrogen combines with oxygen. So dinitrogen, it combines with oxygen only at very high temperature, about 2000 Kelvin. It forms nitric oxide, that is nitrogen. It combines with oxygen at a very high temperature. It forms nitric oxide. Now let us see some of the uses of dinitrogen. So the dinitrogen, it is used in the manufacture of ammonia and other industrial chemicals containing nitrogen. And the second one, because of the inert nature of nitrogen, it finds a lot of uses to give inert atmosphere in the metallurgy. For example, in iron and in steel industry, inert atmosphere of nitrogen is required, because what happens is oxygen, it reacts with metals to form oxides. So to prevent this, inert atmosphere of nitrogen is required. So it is used in the metallurgy. And liquid nitrogen, it is used as a refrigerant to preserve biological material and food items, and it is also used in cryosurgery. That means the low temperature surgeries, it is used. Now let us see the anomalous properties of nitrogen. And we have seen that all the second period elements in every group, they show some anomalous behavior compared to other elements in their respective groups. Anomalous means here the different properties compared to other elements. So here nitrogen also exhibits properties different from the rest of the members of the same group. So it is due to the smaller size, high ionization, enthalpy, high electronegativity, and the non-availability of d orbitals, that is absence of d orbitals. So let us see what are these anomalous properties. So here the first different property, anomalous property, is nitrogen is a gas while others are solids, and nitrogen exists as a diatomic molecule, that is N2. There is a triple bond between nitrogen and nitrogen. On the other hand, phosphorus, arsenic and antimony, they form single bonds as phosphorus, arsenic and antimony. There is a single bond, while bismuth forms metallic bond in elemental state. And one more thing, nitrogen single bond is weaker than phosphorus bond, because nitrogen is very small, and here nitrogen there is a lone pair of electron on this. There exists a lone pair of electrons on both the atoms, so the repulsion between the non-bonding electrons is high. Therefore, the bond becomes weak. And the nitrogen, it cannot form d-pi bond because of the absence of d orbitals, whereas other elements can form d-pi p-pi bond because they make use of their empty d orbitals in valence shell. So these are some properties of nitrogen which are quite different from other elements in their group. Thank you.